Hello, I'm an acid again, and welcome to the second part of Acids and Bases. I am Mr. Fowley, in case you forgot, and we're going to start talking about strong acids and bases. So, strong acids and bases ionize 100%, that means completely. This is why the concentration of HCl equals the concentration of H positive. And remember, H positive is the exact same thing as H3O positive, and it's the exact same thing as the number of protons. And that's kind of the deal. So when that happens, that means you can find the concentration of H positive from a strong acid or OH negative from a strong base. Remember, double the OH is for poly OHs. So BaOH taken twice. If my molarity is 0.2, double that would be 0.4. Remember, you do not double the H positive for polyprotic acids. So H2SO4 0.2 is still the same 0.2. So if we were to look at it under pictures, see how this is 100% ions. That's a weird looking 100% ions. And this one is about 5% ions. So it's weak 100%, or I'm sorry, it's strong 100%, or it's weak less than 5%. So if you were a strong chemistry student, you'd have 100%. If you are a weak chemistry student, you don't have 100%, but it's even worse than that. That means you have less than 5%. Right, or that's not very good. All right, so strong acids completely dissociate, just another picture showing the same thing. 6 strong acids, get your memorizing hat on: hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, sulfuric. Okay, got to memorize them. Okay, we'll refer back to them, but you got to memorize them. However it is, you got to do that. All other acids are weak. So if I said the people that I like in class are Ryder and Travis and Good Lily. Do I like Bad Lily? No, she's terrible, right? Do I like Allie? We don't even have to ask. No, of course not. Do I like Jack? No, I don't like Jack. Sorry, Jack. But that's the idea. So if you're not on this list, you're on the naughty list, okay? The strong bases are group 1 and 2 hydroxides. So on the periodic table, if I drew a periodic table, this is group 1, this is group 2. Everything else is no. Weak bases are other hydroxides, or end in something NH2, or end in COO negative, or just end in a negative. Remember, water is a base as well as an acid. All right. Weak acids and bases ionize less than 100%. I said this, typically less than 5%. They're shown in pictures, and I showed the pictures up above. So now let's get our calculators out and do some math. There are equations you need to know, which are 3 through 6, okay? So there's a couple of other ones that are in there. You need to know pH plus POH equals 14. And then the one that I give you that nobody uses is the concentration of H positive times the concentration of OH negative is 1E negative 14. So that means I'm going to get my 7th grade math class hat on and do this. Okay, now I want to tell you this. Log. Logs are exponential relationships to the powers of 10. Blah, 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 blah. A log is a button on your calculator that gets you the right answer. Okay, so we're going to be talking about that and how to put it in. Okay, give the pH of the following. pH, Roman numeral 3, pH equals negative log of H positive. Now remember, this is a strong acid, so that means all I'm going to do is negative log of 0.1, and that is on negative log 0.1, enter 1. There we go. I'm a winner. 0.35 molar H positive. I want to find the pH of it again. pH is negative log of H positive, negative log of 0.350, negative log 0.35, enter, is 0.456. Okay? 0.005 molar H2SO4. Okay, it's a strong acid again, but it's got 2 H's. Do I double it? Do I double it? Do I double it? Not for acids. So all I do is I negative log 0.00500. Negative log 0.005. Enter, and I get 2.30. we don't need to worry about sig figs on this, okay? The real reasoning for sig figs, if you log something, the number of significant figures, the number of digits you round to, is where the number of digits you get here equals the number of decimal places when you log it, but we don't care. Give the H positive of the following. Okay, so H positive equals 10 to the negative pH. Okay, I'm going to rewrite that because I put numbers in. And so 10 to the negative pH. See, so I'm looking at Roman numeral or little v, right? Which is going to be 10 to the negative 2.4. Easiest way to get that, believe it or not, is to hit the second log button. Second or shift log or second log, negative 2.4, enter, and you get, I'm going to write up here, 3.98 E negative 3. If you don't write the E negative 3, you're wrong. That's the most important part. And I'm doing H positive, so that does have a unit of molar. pH at 8.6, 10 to the negative pH is 10 to the negative 8.6. Second log negative 8.6 is 2.51 E negative 9. 2.51 E negative 9. pH of 7.0, 10 to the negative 7.0 equals 1.00 E negative 7 when I put that in calculator. Not bad, right? Give the pOH. Oh, pOH. So remember, negative log of OH negative equals pOH. And that's my first thought for pOH. So this is a strong base, group 1 hydroxide. So negative log of 0.2. Negative log 0.2 is 0.699. Uh-oh, I got a double hydroxide here. Do I double my hydroxide? Yes, I do. Strong bases, I double it. Negative log 0.003. Whoops, double it. 0.006. Why can't I find my button to erase? 0.006. Negative log 0.006. Enter. 2.21. All right, now I just have OH negative, so if I want pOH again, I'm going to negative log 2.5 E negative 4. Negative log 2.5 exponent negative 4 is 3.60. Now I want to show you these first parts that we've been looking at seem to be exactly the same, but they're not really exactly the same. Notice how we've got pH. I'm jamming up my computer, that's for sure. So we've got pH is negative log of H, and pOH is negative log of OH. So notice how I've got, I keep trying to highlight here. I'll go back to deleting. So pH and then pOH, and it's negative log of H positive, and pOH is negative log of OH negative. Okay. So this is going to be the same thing. OH negative is going to be 10 to the negative pOH. 10 to the negative 6.1. This would be 10 to the negative 13.2. This would be 10 to the negative 1.75. So I hope you can see how this is working now. Second log negative 6.1 is 7.94 E negative 7 molar. Second log negative 13.2 is 6.31 E negative 14 molar. And second log negative 1.75, enter, is 0.0178 molar. Okay, now we get a little bit trickier than that, okay? Find the pH, that's the acid measure of a base. So what I'm going to do first is if I have a base, if I have NaOH, I'm going to first convert that into pOH. Then once I get pOH, I'm going to convert that into pH. Okay? So to get pOH equals negative log of OH negative. That's going to be negative log of 0.2. Negative log 0.2 is POH is 0.699. So now I want to get pH. pH plus POH equals 14. So 14 minus 0.699 is my pH. pH equals 14, whoops. I'm using a stranger's calculator, so I can't make it work. 14 minus 0.699 is 13.30. That's pH. Find the OH negative of a solution of 0.2 molar H positive. Okay, so notice how this is weird because I'm finding OH of an acid. Okay, so if I want to find OH to H, my best equation for that is OH negative. Well, I guess it's H positive. H positive times OH negative equals 1E negative 14. So just to show you, hopefully my thing, of course it moved. I added a couple of equations. Let me put this back down here so it'll settle. But I wrote by hand 2 equations. And I said, oh, we hardly ever use it. So of course we're going to use it. Oh, come on, 4. So we have that. We have 1E negative 14. These are the 2 that I added on here. So we're going to use those. So H positive times OH negative equals 1E negative 14. So I'm going to do 0.2 times OH negative equals 1E negative 14. So OH negative equals 1E, whoops, that's pi, 1E negative 14 divided by 0.2. That's going to be 5E negative, 5E negative 14.
What is it, 5?
I
got 4.5.
Well, and that is it. Toodles. Toodles.